Hello everyone, in this video we will create an AI character that can move using root motion. We will create this behavior such as walk to the player, stand still, and turn to the player, walk back when the player go close to the enemy, and attack the player, and mass walk to attack, and the last one is avoid each other if we have many enemies in the scene. So let's start by go to enemy folder, right click, create blueprint class, character, name it CH enemy. Then for the mesh, we choose SKM many simple. In location, Z is -90. The rotation is -90. Right click, animation blueprint, and choose SK mannequin, create. Name it ABP enemy, and then use melee locomotion blank space. Connect it to output pulse and add new variable. Name it speed size. Variable type is float. Add another variable, name it speed forward. Get speed size and connect to size, and get speed forward, connect to speed forward, and create a slot, default slot. This slot we can play the animation montage. Apply it in the mesh and anim class, search for ABP enemy. Click on mesh, add static mesh, name it AMX. The parent socket is hand off. Location is -12.5 and -0.5 and 15.3. Rotation 274.5 -66.3 and -301.3, and find our X static mesh. At enemy folder, we have BPI enemy animation blueprint interface, and inside it there is each enemy function. Then add new function, name it set move speed. Add input, variable name is size speed, variable type is float, and add new input, variable name is forward speed, variable type is float too. And then go to class setting, add this BPI enemy animation, double click on set move speed and set speed side to side speed and speed forward. Now let's test it. Add the C8 enemy into our scene and the rotation is 180. Then go to ABP enemy, click on class default and set root motion from everything. Go to C8 enemy on event tick, get anim instant, call speed, set move speed, and set the forward speed to 1. Play test. Now our enemy can walk forward. Go to C8 enemy and disconnect this, set move speed, create a custom event, name it, go to target point, add input, variable name is target point, and variable type is vector. Then add variable, name it path point. We want to find the point that the enemy have to walk to the player character, and variable type is vector array. First we clear this array, then call find path to location synchronously, get actor location, name it to path start, and the target point is the path add. And when the return value, we get the path points and set it to our path points variable. Then add new variable, name it next target location single, and add new variable, name it begin target location, get path point and get a copy 0 index. It is the begin target location, and then get a copy from path point index is 1, set it to next location. And we want to debug draw the points that it take to the player character, get path points, call for each loop, then array element, we call draw debug sphere, radius set it to 5, duration is 0.5, and thickness is 10, and line color use yellow color. Go to our third person character event graph, and to debug it we have to get one key And when we press 1, get all actor of class, choose CH enemy. And for each loop, cast to CH enemy, then call go to target point, and the point is player location, get actor location. We have to add name mesh bound volume inside our scene, and then scale it to cover our full scene. We create this to make our enemy know the path to walk to the character. Now let's play test. When we press 1, we can see the path that the enemy have to take to go to this player character. Press 1, and here is the path. Another value that is very useful for our enemy is path distance between the player and the enemy. Create variable, name it path distance, and variable type is float. Add function, name it find path distance. First, we set the path distance to 0, and then get path points. Call for each loop, get path points, and the length, subtract it by 1. For the array index, compare it if it is greater or equal to this length, subtract by 1. Create a branch, and if it falls, we get path distance, get array element, find distance between two vectors, and then get path points, get a copy, and use the array index, add it with 1, and then connect it to vector 2, because we want to find the distance between the first point and the next point, so we add it by 1 index. The path distance, add it with this distance, and set it to path distance, make it to false. And when it complete, we get this path distance, the total path distance value. Call return. Go to event graph, go to target point. Before we call for each loop, we find path distance. Then create a event any damage to receive the damage from the player. Add health. The health set it to 30. Get health. and subtract it with the damage that the enemy receive and set it to hell. Get mesh, play montage. We play this standing react light from left, create animation montage, add it to this montage to play. Go to mesh and search for collision. Use custom collision preset and set visibility to block, and this camera can set to overlap or ignore. Capture component, create custom and visibility to block and camera to overlap. Let's play test if the enemy receive the damage or not. And attack. Now it reacts to our player. To make our enemy walk to the player, we create a custom event. Name it walk. Add variable. Name it front forward speed. Add variable. Name it side speed. Then we set forward speed, get forward speed, and call loop, and the target is 1. Alpha is 0.05 and connect it to forward speed. We use this because we want the character to transition from standing to walking smoothly. And set side speed, get side speed, copy this loop, connect it to A, target B is 0, connect it to side speed, and then get anim instant from mesh, call set move speed, get side speed, connect it to side speed, forward speed to forward speed. To walk to the character, we have to rotate the enemy to the character. Add function, name it smart follow player rotation, and call return. Add output. Variable name is arrive target, and then variable type is boolean. Add output. Variable name is rotation, and variable type is rotator. Go to event graph, and we call this smart follow player rotation. We not yet have the logic in this function yet. If it arrives, we create a branch. If it true, we call go to target point again and get player character get actor location into target point, and if it not yet arrived at the target location, set actor rotation and use this rotation as the new rotation, and we call do one, create a custom event, name it reset target point, name it to reset. And if we set actor rotation, we call this reset target point. Event tick, we delete this move speed and call walk function. Inside this smart follow player rotation function, we call line trace by channel, then get actor location to start and subtract it with Z500, connect it to add. And for the out hit, break the result and expand this. And for the location, we select and use this return value as the index. And if it hit, we use this location, hit location. If it not hit, just get actor location. And add local variable, name it ground location. Set variable type to vector and set it to ground location. And to know that it is arrived at the target or not, we have to get ground location and get next target location, subtract the ground location with the next target location, multiply, and then get target location, get begin target location, and get next location, break vector and break these two and make vector and connect x to x, y to y, because we don't want to use the z value. Get unit direction vector from this begin target location to next target location. Then multiply it with this vector. Delete this multiply. We break it and break this unit vector. X multiply with x, y multiply with y, and z multiply it with z. add it together. And if it greater or equal to, and create n, get ground location, and call the distance between ground location and next target location less than, set it to 40, and this is the arrived target, and connect it to return node. Now to find the rotation, we get actor location, get next target location, and get unit direction from actor location to next target location. Then make rotation from X break vector and make rotator. We only use your value. Then loop between actor rotation to this rotation. For the alpha, similar to our player character, we get actor forward vector, get actor location, get unit direction to the next target location, and dot product between these two. Equals degree divide it by 180, multiply it with 0.5 and 0.01. Then add new variable and name it is near. Set it to boolean, and if it is near the character, we select float. A is 1, B is 1.6. Then multiply it by 0.01. Add it with this value and connect it to alpha, and use this as the rotation. Compile and save. On the begin play, we go to target point, and for the rotation, set it to shortest path is true. If the character arrives at the target point, they will call the go-to target again. But it's not updated with the character location. So in event graph, we can go to target point and delay for 1 second, or we can call the random float in range. Min is 0.7 to 1.2 duration, and when it complete, call go to target point. Play test, and if we walk to the top of the location, this enemy will follow us. But it don't know that it is near the character and still walking. We have to stop that. Add new variable, name it is too near. And add new variable, name it is too far. And add new function, call it is near player. Input, variable type is float. Too near distance. Add variable, name it far distance. Add variable, name it too far distance. Then get path distance. It is less than the far distance, and set it to is near. Or you can change this far distance to near distance. Then get path distance and compare it less than the too far distance, and we set it to is too far, and get player character, get actor location, get actor location, find the distance between the player character and enemy character, and call less than too near distance, and call n boolean. We use this z value of the player character location and enemy location z value. Subtract it, call absolute, and call in range. Min is minus 20 and max is 20. I'm gonna it to n. This one will prevent it from confusing the system when we have different height of terrain. And set is too near. And go to event graph. call this is near player. To near distance is 210. Near distance is 320. Too far distance is 760. And then we get anim instant and call is any multiplying and create the branch. We walk to the player if it is false. Create another custom event and name it stand still. Copy this set move speed and the forward speed and side speed. For the value B is 0, forward speed and side speed is 0 too. And then in the event tick, get is near and create a branch. If it's true, we call stand still, and if it false, we call walk. Let's play test. Now when the enemy walk to the player and arrive at near the player, it stop walking, and if the player go far away, they will walk to the player again. We create a turn to the player, go to stand still, then get anim instant and call is any multiplying and create a branch. If it false, we get is too near, then create a branch, and we only turn when it is false. Then add new function, name it dot product degree. Get actor forward vector, get actor location, get player pound, and get actor location, get unit direction. Then we call dot product and call equals degree. Return and connect it to the return node. Add new function, name it turn side. We have to choose which side that we have to turn, left or right. Get actor right vector, get actor location, get player pound, get actor location, then call get unit direction from the actor location to player pound location. Dot product and call equals degree. Copy all of this and get the right vector and multiply it with float -1 for the left vector and compare it which one is less than, and return this boolean. We have to turn to that side because it has the nearest degree to the player. Event graph, get dot product degree and set it to pure function, and this turn size set to pure function too, and this degree, if it greater than 55 degree, create a branch, get turn size and create a branch. If this true, get mesh, play montage, and copy and paste it. If turn size is true, we go to animation and create the animation montage from turn right and use it to montage to play. And if it fall, we turn left. Let's play test. Now it stopped working, and if the character walk different side of the enemy will turn to the player. Thank you very much for watching, and if you have any question, please leave it in the comment section below, and please subscribe to my YouTube channel. It really means a lot to me. Thank you very much, and see you in the next video.